As you know, I like to show you various approaches, starting with what I think is going to be the most effective approach, and then kind of going from there and telling you some other options as well. So let's actually start with using Desmos. Here, that's going to be the best option. In other words, whenever you have an X on the left side and an X on the right side, and especially if it has a root or something kind of funky in it, I think Desmos would be pretty convenient. So let's go ahead to the upper right corner. Open up Desmos, get it into a viewing window that you feel comfortable with. And we really have two options here. We could go ahead and just type it in as we see it. And notice I'm gonna have to kind of zoom out a little bit. I could press Control- to do so. I think that's a pretty good viewing window. Notice down here you have the keyboard. I'll open that up. We'll click the square root key and then do 4x plus 16. I'll press the right arrow key so I can get out of the root and put equals, and I'll do the x plus 1. Now it might seem weird that all of a sudden I just have this vertical line, but the idea is it's giving you the solution as x equals, which if you graph x equals a number, it's just that vertical line. So notice we get x equals 5. There is no x equals -3 here. You could zoom out and you could see at -3, there is no vertical line. So right away we get the correct answer is Roman numeral 2, which means answer option B. And we could move on. Now to show you another approach is, let's say you had decided to break up each of these sides into their own function. You could say the left side is its own function and you don't even need to put y equals. You can if you want, but notice it's not going to change anything. And then same thing here, I could put x plus 1 as its own function. Same idea, I don't have to put y equals. Now notice in this scenario, we're looking for where those two functions intersect, more specifically just the x coordinate of that. So we can see here is the intersection, the x coordinate of which is 5, again making the correct answer B. And I can show you why if you want to understand the algebra. Now at this point, if you're just like, I'm good, I understood the Desmos, good to go, you can stop watching at this point. But for those of you who are like, but how would I do it by hand for my actual math class? Well, good question. Let's go ahead and square both sides, and then the square and square root cancel so that we get 4x plus 16 equals. Now keep in mind, when you're squaring something, it means times itself. So we're going to go ahead and multiply by itself. And then that involves essentially distributing in this FOIL process where I get x squared plus 1x. When I distribute the x, now I'm going to distribute the 1 and I get 1x plus 1. And then here we're going to go ahead and combine like terms to get x squared plus 2x plus 1. And then you always want to remember, if there's one type of x, like just x to the first or just x to the second, you're going to get x's on one side, numbers to the other. Kind of like in the scenario I always share with you, if I have like x plus 3 equals 8, I'll just get x's on one side, numbers to the other. But whenever you have more than one type of x, you want to get everything equal to 0 so that you can then factor and solve accordingly, right? And in this case, we do have two types of x, to the second and to the first power. So let's get everything equal to 0. More specifically, I want to keep the leading coefficient positive. So I'm going to move everything to the right, which means subtracting the 4x over here, which makes that -2x, subtracting the 16, which gives me -15, and all that's equal to 0. And I'm confident you could very likely just factor it on your own and solve it by saying, okay, the numbers that multiply to 15 and are different by 2 are 5 and 3. To multiply to get a negative, you have a positive and a negative. The bigger one's negative. And we get our two solutions by setting this equal to 0 and this equal to 0. And we get either x equals 5 or x equals -3. Now, you're going to see why Desmos was definitely superior here, other than the fact that this has taken quite a while. But when you go back to the original function and plug in these two options, you have to figure out which, if any, is extraneous. Well, if I plug in 5 plus 1 is 6. And on the left side, 5 times 4 is 20, plus 16 is 36, the square root of which is 6. So that matches out. However, when I plug in -3, I get -2 here, and then -3 times 4 is -12, plus 16 is 4, the square root of which is +2. So since those aren't equal to each other, that's extraneous, because it's an extra solution that's not valid. And again, we get our final answer as B. So now you know how to do it various ways, but Desmos was absolutely the most efficient way.